All right, it is 10 o'clock my time. So, how about we go ahead and get started? First off, can just if you have any trouble hearing me, just raise your hand during the presentation, and I will turn my volume up. But okay, well, I want to thank you all for joining us on this Friday morning, and welcome you to our webinar on our HMIWorks HMI development program. So today we are going to be, this is going to be a little shorter presentation than usual. So we're going to be going over our HMI features and functions. We're going to look at some of the specs for our HMI controllers. That would be our TPD and VPD series of resistive touchscreen controllers. And then, of course, we are going to talk about HMIWorks, give you an overview of the software's features and how it works. And then we're very briefly going to talk about how you would design your HMI GUI with HMIWorks, and then talk about programming some basic functions with Ladder Designer. If you are looking for a more in-depth discussion of either designing a GUI with HMIWorks or with programming with either Ladder Designer or C, we have a lot of resources for that. So I would be very happy to email those to you. And if you hold to the very end, I can drop some links in the chat if you want to go and look at those. Speaking of holding to the end, I do ask that you please hold your questions until the end. If you think of one, feel free to type it into the Q&A box that you see on your Zoom interface. Or if you would rather answer live on the air, then you can just hold till the end and then raise your hand during the Q&A, and you can speak on mic. And I have Robert with me today. He's one of our application engineers here at ICPDAS USA, and he's going to be able to answer some of your more technical questions. So if this is your first time joining us, a little bit about us. We are ICPDAS USA. ICPDAS was established in 1993. Our headquarters is located in Hsinchu, Taiwan. ICPDAS USA was launched in 2001 to support the North and South American markets. We have over 200 R&D engineers, and we work closely with them to develop new products and to support our customers. Most of our products are RoHS compliant, meaning they are lead-free. We're also ISO 9001 certified here in the States, SGS certified in the UK, and we are a Windows embedded partner. So again, if we're going to be talking about HMIWorks, we have to first talk about our touchpad controllers, since it is a program designed from the ground up to work with these, to work with the touchpads. So ICPDAS has two types of touchpad: the TPD series for home and building automation, and the VPD series for industrial applications. These are cost-effective solutions that can be used as an HMI and as controllers. Well, and both, obviously. The TPD series have wall boxes for easier mounting, and the VPD series have an IP65 front panel for more rugged environments. So the sizes range from 2.8 to 7 inches on the TPD and 3.5 to 7 inches on the VPD. And there are options for serial and Ethernet communications, including Power over Ethernet, or PoE. So what you're looking at here is just an example. There on the right is one of the TPD 280 series, the 2.8-inch screen, and it has the two mounting options. It either mounts inside the wall inside the electrical box, or with the external wall box, as you see. And there's the TPD 700s. That's the 7-inch screen there on the left, and that's just a simple application diagram there on the bottom. It shows the TPD and the VPDs communicating through an RS-45 converter on one of our XPack programmable automation controllers. So these can be used for distributed control in an industrial situation, or if you just need a place to view and access status or data. That's also another use for them in this distributed diagram. So let's look at our TPD 280. So this is a very inexpensive, easy to use, and easy to program HMI or human machine interface that is most often used in home and building automation applications. So what it is a 2.8-inch resistive touchscreen controller that communicates over RS-485 only in this version. In the 283, I believe that, the 283 would be the RS-485 or Ethernet version. RS-485 and Ethernet version. It has a 32-bit RISC-based CPU, and I believe all of the touchpads that we're talking about today have the same CPU. And it can store 4 images to use as part of the interface and has an IP40 faceplate and an operating temperature range from 4 degrees Fahrenheit to 158 degrees Fahrenheit. So still pretty tough, even in the home and building automation version. Let's just take a look at the external wall box for these devices. This is called the EWB T28, and it's just what you see on the tin. You can see the exploded diagram here on the right showing how it all fits together. And just to give you an example of what is available in our TPD 280 family. Oh, it looks like the T83 is Ethernet only, so I was right the first time. So we have a number of options, and the T80U modules also have a USB connection, but that is going to be for software and firmware updates only, so not for communication between the HMI and different modules. And see the end of our selection table here. So we have the Ethernet versions in PoE, and we also have some of these TPD 283 modules, which do have RS-485 and Ethernet. In addition to the TPD 280 series, we have the TPD 430 and TPD 700, and these have mostly the same specs as the TPD 280. However, these are available in the 4.3-inch and a 7-inch screen. So, like I said, most of the same specs, but with the bigger screen, up to 64 megabytes flash storage on some of the larger models, giving you more room for pictures and animations. These devices are perfect for, say, a conference room or an auditorium where you want a nice big display that's easy for anyone to use. You can program lighting scenes, control HVAC equipment. You can control projectors and projector screens, and do it all from one or from multiple locations. And this is just an idea of what we have in the 430 and the 700 series. So as you can see, a lot of the same specs as the 280. All right, let's talk about our VPD series. So the VPD series are our industrial touchpads. They have, so the 130 series features a 3.5-inch high-resolution color touchscreen LCD with touchscreen capabilities. It's easy to deploy these into all kinds of automation systems, make them more intuitive and efficient. You can either set up new system installations or complete system retrofits. The VPD series stands out for its wide variety of communication methods. Its built-in communication ports include RS-232, RS-485, and USB interface that enables integration into the system, allowing users to control, monitor I/O at the remote side, and update firmware directly from a central computer. That's the USB interface. Also, the built-in non-volatile storage makes VPD series more reliable for rugged environments. But again, it is built on a lot of the same components as the TPD series. And let's go ahead and just look at our selection here. Like I said, lots of communication options for the VPD series, in addition to the tougher IP65 faceplate. And the rubber keypad gives you some options that are easy to it gives you some control options that are easier to use when you have, say, when you're wearing gloves. All right. So now that we have talked about the platforms that HMI works on, let's actually talk about HMI Works. So, HMI Works is a software suite for developing programs for our TPD and VPD controllers. It is not a free platform for developing programs on third party controllers, but the advantage is that this program was again designed specifically for use with our TPDs and VPDs, making it easy to program for them with the presets that are already in the HMIWorks software. It eliminates compatibility issues. Let's talk a little bit about HMIWorks features. So the touchpads must be programmed with the HMIWorks IDE, that is integrated development environment, and you can download HMIWorks for free from our website. HMIWorks allows for programming in C language and ladder logic. In this webinar, we will focus on just ladder. So it has widgets and a graphic library that help you create user-friendly HMIs. The touchpads can communicate with the Modbus protocol and can act as a master or a slave device. They also have Decon protocol, and users can program their own protocols. In this webinar, we will just be talking about some of the most of the basic features of HMIWorks. Again, we have had webinars and training videos in the past that go into a lot more depth. So if you're interested in that, just let me know and I will send you some links. Okay, so now that we've talked about the specs a little bit, let's talk about what you can actually do with these controllers when you program them. So first off, if you're an engineer or an IT professional, then all of these controllers are C programmable. We do provide an environment to program them in C, but we also have a very useful and easy to use WYSIWYG or WYSIWYG, what you see is what you get, editor through HMIWorks. That's designed specifically to be used by our TPD and VPD controllers. Okay, HMIWorks supports a wide range of shapes and widgets that you can use to program. You can use to design your GUI, including rectangles, ellipses, text, pictures, lines, text push button, slider, bit button, hotspot, checkbox, label, timer, paintbox, object list, providing some of the most commonly used functions such as drawing, event handlers, and timing control. We also offer a drag and drop editor for designing your GUI, which is, like I said, just a WYSIWYG editor for all of the design elements. Graphics are easy to adapt, easy to expand, and easy to transform. HMIWorks supports graphics and provides users with a variety of built-in graphics for common situations, and you can also add your own graphics to the library, depending on the storage space on your particular module. And again, to program the actual logic functions on these controllers, like I said, we do provide an environment to program functions in C. We offer a fairly extensive library of demo programs for both C and ladder that can get you started controlling things like HVAC functions and designing your own programs. So some of our demo programs include a server client demo, count up and count down functions to read and display power meter readings from our smart power meters. A program that reads and displays power meter readings from our smart power meters. We can also have a trend graph demo and a program for lighting control, temperature display, and communication detection. And then, in addition to that, we have a ladder logic environment called Ladder Designer. so so that you can set up start and stop functions that respond to your I/O readings. So between the drag and drop editor and ladder designer, you can design the look and function of your TPD and have it performing some basic functions in well under an hour. Okay, so once you install and run HMIWorks, this is what a standard workspace is going to look like. You have your workspace and toolbox there on the left, the frame design space, which is where you're going to drag and draw your different items for the GUI. You have the inspector and libraries. Inspector inspects elements, and the libraries is a library of functions and objects. And then you have the results window for testing and debugging your functions there at the bottom. So when you start HMIWorks, you can either work on an existing project or start a new project. Pretty basic. When you start a new project, again, this is the advantage of using HMIWorks. We have presets for all of our TPD and VPD modules there on the left, so you don't have to worry about programming at the wrong size or wrong resolution. But you can, some of these modules, some of these controllers offer both a portrait and landscape mode, and then so you designate that there in the middle, and you decide whether you're going to use C or ladder there at the bottom. And then this is what your first frame is going to look like. And an HMIWorks project can consist of, and will usually consist of, multiple frames. HMIWorks frames are a lot like, say, web pages, and you navigate between them from frame to frame. So you'll have a home page that you design, and that's one frame, and you may want to navigate to a different page. Maybe you have a different page for lighting control and a different page for temperature control, and you just navigate between them. But this is where you're going to be doing the work of designing your GUI. You can grab objects from the library or from your toolbox, and let's see. There's also the configurations page where you can change any of those defaults once you're in the project. But this is what your toolbox on the left is going to look like. These are all the objects you can draw: arrow, rectangle, ellipse. You can draw a text box, a picture, or a line. We also have these are some built-in widgets. So some of those would be animated. Arrow, text push button, slider. You get the idea. And then there are system functions like the timer. So when you are designing your HMIWorks frame, this is what a very basic frame is going to look like. So what you see here is just a picture, a couple of text options, a button that takes you to a different frame, and here we have 4 analog input channels, and what you see here in the middle. These are each. Let's see, the box is an object, and inside is a label, and the label is tied to a tag, and the tag represents your analog input values. So this is just a very basic program for reading analog input values. Okay, so that is all I want to say about designing the GUI. Let's talk a little bit about Ladder Designer. So ladder logic is a programming language that is represented by graphical diagrams based on the schematics of relay logic hardware. So conditions on the left lead to outputs on the right, and logic functions are implemented by developing a ladder diagram. And the reason why it's called a ladder is because it, looks like a ladder with rungs on, or with the functions going into the horizontal rungs. So Ladder Designer is a tool inside of HMIWorks that helps you program functions. Ladder Designer makes programming basic logic functions and even slightly more advanced functions very easy with its libraries and drag and drop menus. And the Ladder Designer consists of 3 parts: the menu bar, the function bar, and the edit space. The highlighted rectangle area is the cursor. So to use Ladder Designers, you are first going to add variables into Ladder Designer, and these can either variables in Ladder can be a lot of different things, and they can respond to physical input and output, and they can also refer to internal memory. So to create a new rung in the ladder, you double click on the symbol of contact, inputs, coil outputs, etc. to open the select variable window. Here you can see the variables you can select from. So each rung in the ladder defines a variable or a function, and inputs and outputs on the left and right respectively can refer to physical I/O variables or virtual tags that deal with internal functions. The rungs in a ladder diagram are essentially a set of nested if then else functions that respond to input values, store and change variables, and trigger outputs. So again, if you want to know more about programming ladder logic functions in HMIWorks, we have a whole series, a 3-part webinar series from a couple years ago that is very good. And again, I would be happy to send that to any of you, and you can email us at sales@icpdasusa.com. We'll display our contact information here in just a second. So this, like I said, this presentation is intended to cover the very basics of what you can do in HMIWorks. But we do have a lot of instructional videos on these topics that go into much more depth. Like I said, we have a 3-part webinar series that will take you entirely through your first HMIWorks project and even getting started programming some basic functions in C. We also have extensive documentation for each of our products and HMIWorks. It is all available through our website, or of course, you can just contact us. So I want to thank you for spending some time with me today and remind you why choose ICPDAS. We provide reliable, cost-effective components designed to fill in the gaps in your system architecture. All of our parts work well with third-party components and systems, and we have a very wide variety of products and solutions to fit any scale project. With that being said, that brings us to the conclusion of my presentation, and let's get into our Q&A session.